Okay, so number 5 is a system of equations that has some fractions. As you can see, the denominators of the coefficients of x are both 5. The denominators of the coefficients of y are both 3. So it is possible that we could just multiply one of the equations through by something in order to create opposite coefficients, and then add the equations together and cancel out one of the variables. As you can see here, it is relatively easy. We could multiply this first equation by 2, which would create a 2/3 y, a negative 2/3 y in the first equation. And then we could add the two equations together, thereby eliminating the y. And if you want to do it that way, that's perfectly fine. But just for the sake of practicing, I would like to clear the fractions just so that we can practice that, because there are going to be situations where multiplying through is not going to be useful at all to us. So to clear these fractions, we're going to multiply by the least common denominator. And in this case, the least common denominator of both equations happens to be 15. It's not always the case that the least common denominator is the same for both equations. Okay, so we're going to multiply the first equation by 15. 2/5 of 15 is 6. So we have 6x minus 1/3 of 15 is 5y equals 15. And the second equation, 3/5 of 15 is 9. So 9x plus 2/3 of 15 is 10. 10y equals 75. Okay, now you could see we still have two equations here where we need to do something with one of them in order to create variables that can be eliminated. So we're going to multiply the first equation by 2. And I'm going to rewrite it down here. So 12x minus 10y equals 30. We will add these two equations together, which will eliminate the y's. 9x plus 12x is 21x. 75 plus 30 is 105. If we divide both sides by 21, we get that x equals 5. And substituting back into one of the original equations, I'll just substitute into the first one. 2/5 times 5 minus 1/3 y equals 1. 2/5 of 5 is 2. Minus 1/3 y equals 1. Oops, 1. So negative 1/3 y is equal to negative 1. So y is 3. So we have the ordered pair 5, 3 as the solution to this system.